Hello everyone. Today we'll deal with properties of rational number, that is closure property, right? Let us deal with closure property. Closure property of rational number. Here we'll deal with closure property, closure property of rational number, closure property of rational number, closure property of rational number, of rational number, closure property of rational number. First one we'll deal with addition. Number one is addition. What is the rule for addition for closure property? Here the rule is the sum of any two rational number is always a rational number. What is that? The sum of the sum of any two rational number, the sum of any two rational number, rational number is always a rational number, is always a rational number. Sum of any two rational number is always a rational number. Right? Let us take two rational numbers. Right? If we take a rational number, if a by b and c by d are any two rational number, any two rational number, then we can say that a by b plus c by d is also a rational number, is also a rational number, also a rational number, also a rational number. Right? Let us take one example. Let us take example here. Let us take an example. Let us take two rational number. One is 2 by 9. One is 2 by 9 and another is 4 by 9. 4 by 9. We add both the rational numbers 2 by 9 plus 4 by 9. Let us add this one. It will be 9. This 2 plus 4, that comes to 6 by 9. 6 by 9. And here you see that 6 by 9 is also a rational number. Right? 6 by 9 which is a rational number, which is also a rational number, which is also a rational number, which is also a rational number, right? Therefore you can say, let us take, understood? That means the sum of any two rational number is also always a rational number, right? If a by b and c by d are any two rational number, then a by b plus c by d is also a rational number. For example, 2 by 9 plus 4 by 9 equal to 2 plus 4 by 9, it is 6 by 9, which is also a a rational number. Therefore, you can say that addition is closed under addition is closed under this property. Very right. You can say that addition is closed and this property closure property. Right. Now we'll do the next one, that is subtraction. Let us take subtraction. This is addition. Number 2 is subtraction. What is that? Next one is subtraction. Let us take subtraction. 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 What is that? What is that? That is, the difference between any two rational number is always a rational number. The difference between the difference the difference the difference the difference between the difference between the difference between any two difference between any two rational number the difference between any two rational number the difference between any two rational number is always a rational number is always a rational number always a rational number always a rational number. Right? For example, if we take two rational numbers a by b and c by d, if we take two rational number, if a by b and c by d and c by d are any two rational number or any two rational number rational any two rational number, if a by b and c by d are any two rational number, then you can say that a by b minus c by d is also a rational number is also a rational number is also a rational number. Right? Let us take one example. Let us take one example. Let us take one example here. Suppose we take two rational number. One is, suppose the rational number is 5 by 9, 5 by 9 minus 2 by 9. Then you are getting 5 minus 2, that is 3 by 9. 3 by 9, which is equal to 1 by 3, which is also a rational number, which is also which is also a rational number, which is also a rational number. Right? So here you get that addition, subtraction, the difference between any two rational number is always a rational number. If a by b and c by d are any two rational number, then a by b minus c by d is also a rational number. That, for example, 5 by 9 minus 2 by 9, we are getting 3 by 9, that is 1 by 3, which is also a rational number. Right? I will deal with multiplication. Let us now deal with multiplication of rational numbers. Right? Let us deal with multiplication of rational number. Closure property. Closure property of rational number. Closure property. Closure property. Closure property of a rational number. Rational number. Let us take multiplication. 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 What is that property? Here, the product of any two rational number is always a rational number. That is the product of the product of any two rational number, the product of any two rational number, two rational number is also is always a rational number. The product of any two rational number is always a rational number. The product of any two rational number is always a rational number. Right? If a by b, if a by b and c by d are two rational numbers, are two rational number, are two rational, are two rational number, then we can say that a by b into c by d, a by b into c by d is also a rational number, is also a rational number. Let us take one example, rational number. Right? Let us take one example. Let us take one example. Example is, let us take one example. Suppose if I take 1 by 5 into 2 by 3. If we multiply this one, 2 1 is 2, 3 5 is 15, that is 2 by 15. You see, after multiplying, we are also getting a rational number, which is a rational number, which is a rational number, which is a rational number. Right? That means the product of any two rational number is always a rational number. Now we'll give next one is division. Next one is division. Now we shall deal with division. Here division. that is division. That is the collection, the collection, the collection, the collection, the collection, the collection of, the collection of non-zero, the collection of non-zero rational number, 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 the collection of non-zero rational number is closed, is closed, closed under division, closed under division, closed under division. The collection of non-zero rational number is closed under division. Let us take one example. That is 2 by 3 divided by, let us take one example. That is 2 by 3 divided by 1 by 3. That is equal to 2 by 3 into 3 by 1. That comes to 2. That comes to 2, which is a rational number, 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 rational number. This is for non-zero rational number. But if we take 0, let us, for example, this one, let us take any rational number, suppose 2 by 3 divided by 0 is not defined, is not defined or undefined. Therefore, you can say that the rational number is not closed under division. Therefore, we can say that the rational number, that the rational number, rational, that the rational number, that the rational number is not closed, not closed under division, not closed under division, under division. Right? Therefore, in the end, you can say that the rational numbers are closed under addition, under subtraction, under multiplication, but not division. Right? Therefore, we can say that, therefore, we can say that the rational numbers, that the rational numbers, the rational, that the rational numbers, rational numbers are closed, are closed, rational number are closed under addition, under addition, closed under addition, subtraction, addition, subtraction, addition, subtraction, subtraction, multiplication, 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 but not under division. but not under division. Right? You have to remember that the rest numbers are closed under addition, closed under subtraction, closed under multiplication, but not closed under division. You have to remember this one, that the rest numbers is not closed under division, but the rest numbers are closed under addition, closed under subtraction, and closed under multiplication, but rest number is not closed under division. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.